All right, let's take a look at arc length in polar form now. You've got your arc length formula. So the integral from alpha to beta squared r squared plus dr d theta squared d theta. Right? This remark should be noted. Be sure when you're finding the arc length that the curve is traced out only once in the interval of integration. Okay? For example, r equals cosine of 3 theta is traced out once from 0 to theta, but if you would have done it from 0 to 2 pi, you're doing it 2 times. Okay, so you got to be a little careful about your interval. Okay, so let's go ahead and think about this for a minute. You've got some thetas and r's here. Your period here is 0. Oops. Or is 2 pi over 1, so I'm going to go up by a fourth of that, so I'll go up by 2 pi halves. 0 pi halves pi, 2 pi halves, 2 pi. And plug that in, let's plug that in, and that in. And so when r is 0, when theta is 0, r is 0, so starting right there. Now let's go pi halves, right? So I rotate pi halves, I go out 2, there it is. So this is 2 pi halves, my r and my theta. So I'm coming around this way, and keep going. And then pi, if I rotate pi, I go out a distance of 4 right there. So I'm going to hit right here. 4 pi, right? R, theta. And keep coming around 3 pi halves, 2 right to there. And then finally 2 pi, 0 back to there. So I've done those 5 points on there. So I do want to go from 0 to 2 pi, would take that around at once. Right? So when I'm finding the arc length, I'll do that. Now for the arc length, we're going to have to take the derivative of r here. So dr, d theta is involved. So let's go ahead and find that. Derivative 2, 0, so constant stays there. Derivative cosine is negative sine. And so dr d theta is 2 sine of theta. Now let's go ahead and find the arc length. So the arc length is from alpha to beta, r squared plus dr d theta squared d theta. And so this arc length will end up being, we're going to go from theta being 0 to 2 pi. Our r here is 2 minus 2 cosine, so the r is being squared. Dr d theta is the 2 sine. That's being squared d theta. And so that ends up being, so I got 4 minus 4 cosine minus 4 cosine, so minus 8 cosine. Plus 4 cosine squared. Plus 4 sine squared d theta. And so let me take out a 4. I've got 1 minus 2 cosine theta plus cosine squared plus sine squared. So plus 1. So I got the square root of 4 is 2. And then I got 1 plus 1 is 2. So I got 2 minus the 2 cosine of theta. I got 2, and then I'm going to go ahead and take out a 2 again on that. So I got 2 root 2, and I've got the square root of 1 minus cosine theta d theta on that. And Now remember, sine squared u is 1 minus cosine 2u all over 2. Right? So if I multiply both sides by 2, I have 2 sine squared u is 1 minus cosine 2u. And so if I take that u and divide it by 2, this would be the same thing. 2 sine squared u over 2 would be 1 minus cosine of u. I do that because I see that right there. I'm going to replace that with 2 sine squared theta over 2. We got 2 root 2, and the integral of the square root, and that 1 minus cosine theta becomes 2 sine squared theta over 2. So I've got another square root of 2 I can pull out front. So now I got 2 root 2 times another root 2. It's 2 times 2, or 4. And I get the square root of sine squared theta over 2 d theta, which is sine of theta over 2 d theta. And now I'm going to let u be theta over 2. So du is 1/2 d theta, 1/2 multiplied by 2. So we've got 8. The integration of sine of u du. The integration of sine is negative cosine u, which is in this case theta over 2. From 0 to 2 pi. So we've got cosine pi is negative 1, so I got negative 8 times negative 1 plus 8. Cosine 0 is 1, so I got 8 plus 8 equals 16. So my arc length is 16. It should be noted, you can determine the reasonableness of this solution by comparing it to like the circumference of a circle with like a similar radius, in this case of about 2.5, right? So you think about circumference being 2 pi r, so 2 pi times 2.5, you get about 15.7, right? So that's like this arc length around this cardioid. I know it's a limosone with this little cardioid specifically, right? So it's not exactly circumference of a circle, but again, you can approximate it similarly that way. All right, let's say we sketch this in polar again, or I'm sorry, in our Cartesian graph here initially. We've got this sine curve bumped up once. Here's part A, we'll do part B, our polar graph. Notice A and B is 1, so this is a cardioid limosome that's symmetric about the y-axis. Theta is 0, I'm going out 1. Here's my point. R is 1, theta is 0. Maybe you want to do like pi 6 or something. Sine of pi 6, you got a half, or 3.5 plus 1 is 1.5, so you're out 1.5. So it's kind of coming around, distance of 1.5 there. Let's do the pi halves too. I rotate pi halves. I'm up 2. It's kind of coming around. In here, we could do pi out of distance of 1. With this pi 1. Oh, this is kind of bad. Anyways, 3 pi half 0. So I rotate. If I rotate 3 pi halves, I'm just stuck there at 0. Distance is 0. Get rid of that. Not a bad idea to hit some other ones, but along the way, you guys to see this. We're coming around again from there. Back to, if I rotate 2 pi, my R is 1. So I'm back to here again. Oops. On that. Okay, so we're going to go from 0 to 2 pi. We'll go around it once on this. So let's go ahead and find our arc length. So we're going from alpha, beta, r squared plus dr d theta squared, d theta. So we're going from 0 to 2 pi, 1 plus sine of theta, that's our r. Dr d theta, right? If I have r, dr d theta would be 0 plus derivative sine cosine. So it's just cosine for dr d theta. Cosine theta is being squared, d theta. So our arc length here is 0, 2 pi, 1 plus sine plus another sine, so 2 sine plus a sine squared plus a cosine squared. Now I know sine squared plus cosine squared is 1. Well, we could do a big mess of integration, and you'd want to you could multiply by square root of 2 minus 2 sine theta and dividing it by that. So you multiply by square root of 2 minus 2 sine theta, top and bottom. But we're going to go ahead and use some software to do this. So I've graphed the cardioid, you can see that, and we're going to go around from this point right here, theta being 0, all the way around it to theta being 2 pi. So, and we're going to do this one with technology. So we're going to integrate. Let me find my functions here. Let me go down to the calculus. It's down here. And I'm going to integrate. And I'm going to go from 0 to 2 pi. And I'm going to go square root. Let's see. I got to put this whole thing in parentheses. Square root of 2 plus 2 sine of theta d theta. And it'll spit that out for you. I'll give you 8 right there. So there's our arc length. You can check that. Do that with your decimals. And our arc length end up being a distance of 8 around. Here we've got this set up. We're going from theta being 0 to pi halves. And I'll do this r squared plus dr d theta squared d theta. It just says, hey, go ahead and find the length of the curve from there to there. And so let's go ahead, let's go to the side for a minute. Whoops. Note r is e to the theta over 2. So dr d theta would be ln of e to the theta over 2. And then chain rule times a half on that. So the dr d theta ln of e, of course, is just 1, is e to the theta over 2 all over 2. Or 1/2 e to the theta over 2. So let's go ahead and do that now. From 0 to pi halves. R is e to the theta over 2, but the r is being squared. And then the 1/2 e to the theta over 2 is also being squared, the dr d theta. So e to the theta over 2 squared, right, or times 2, right? Power of a power. We're going to go ahead and multiply that. That'd be e to the theta. And I got a half squared, which is a 4th. And then e to the theta over 2 squared should be e to the theta. So I got e to the theta plus 1/4 e to the theta. So I've got the integration of 5/4 e to the theta d theta. Well, square root of 5 is square root of 5. Square root of 4 is 2. Let me take that constant out. I'm left with e to the theta. And that's, let me put that in radical form. That's to the 1/2. So we've got e to the theta over 2. So we've got square root of 5 over 2, e to the theta over 2 d theta. So I'm going to go ahead and let u be theta over 2. So I need a 1/2. I gotta offset it. And so I've got square root of 5 e to the u du. So I got square root of 5, 1 over ln of e to the u du. Well, I'm sorry, plus c, but in this case it's a definite integral, so we're going from 0 to pi halves. So we got square root of 5, 1 over 1, so e to the theta over 2, 0 to pi halves. Square root of 5, e to the pi 4th, minus square root of 5, e to the 0 over 2. Well, e to the 0 is 1. So we have square root of 5, e to the pi 4th, minus square root of 5 times 1. So our arc length, let me take the square root of 5 out. I have e to the pi 4th minus 1. There's our arc length. So our last example here is to find the tangent line to a polar curve. So again, regard theta as a parameter, write parametric equations for the curve following equations. Okay, and so that your dy dx will end up being dy d theta over dx d theta, which is shown there. All right. So let's go ahead and use that for this one. Find the points x, y on a given curve with the tangent line is horizontal or vertical. So number 1, my r here is 1 minus sine theta. And so my dr d theta would be negative cosine theta, right? And then let's go ahead and find first our horizontal tangent. Horizontal tangent. So our horizontal tangent would be, where is the slope equal to 0? Well, the slope would be equal to 0 wherever dy d theta is equal to 0, right? And dy d theta is this dr d theta sine theta plus r cosine theta. So the horizontal tangent, just make a note, that's where your dy dx would be 0. In other words, the numerator must be 0, right? The numerator must be 0. So dy d theta equals dr d theta sine theta plus r cosine theta. And so we want our dy d theta to be 0. Our dr d theta here is negative cosine. That's our dr d theta, and then the sine stays the sine, plus r. Our r here is 1 minus sine times cosine. Let's go back down here. So we got 0 equals negative sine cosine. Distribute that, plus cosine minus sine cosine. And so we have 0 equaling, I also have like terms there, cosine minus 2 of those sine cosines. Now I can factor out a cosine. And then I can set each of those factors equals 0. So where does the cosine of theta equal 0? Where does 1 minus 2 sine of theta equals 0? This would be pi halves and 3 pi halves. And then 1 minus 2 sine of theta, that would be where the sine of theta is a half. All right, where does the sine of theta equal a half? Pi 6 and 5 pi 6, right? Now, note, for right now, I'm acting as if there's no restrictions for theta. In other words, I'm not bound between negative pi fourths and pi fourths. We'll address that in a minute. But let's talk about where these horizontal tangents would be. I'm going to address this theta being pi halves in just a second. I'm going to ignore that one for right now. I'm going to come back to that with the vertical tangent for just a second. So right now, if I let theta be 3 pi halves, theta is 3 pi halves, my r, all right, r equals 1 minus sine of theta, 1 minus sine of 3 pi halves. I know the sine of 3 pi halves is negative 1, so I got 2. So my r is 2, r theta. So I'll have a horizontal tangent there. Then I do the same thing for pi 6 and 5 pi 6. So I plug in pi 6 for theta, and that'll spit out, end up being a half, and then 5 pi 6 as well. There is this. And these are my horizontal tangents. Now let's go to our vertical tangents. Vertical tangents. So this is where dy dx would be undefined. All right, what makes it undefined? When the denominator in this case would be dx d theta. When is dx d theta equal to 0, right? Our denominator. So I'm going back up here. When is this 0, right? There's my dx d theta. Let me erase all. When's my dx d theta, which is right there? When is that 0? So I have dx d theta equals dr d theta cosine theta minus r sine theta. And we want to know when dx d theta is 0, My dr d theta here is negative cosine, we said, times cosine, minus. My r is 1 minus sine times a sine. And so we've got 0 equal negative cosine squared minus sine plus sine squared. So I'm going to replace this with cosine squared is 1 minus sine squared. Remember, sine squared plus cosine squared is 1. So let me replace that. So I'm just left with sines here. Negative 1 plus sine squared plus another sine squared, so plus 2 sine squared minus sine. So this is quadratic in form. So I have 0 equaling 2 sine theta plus 1 sine theta minus 1. So where does sine of theta equal negative a half? And where does sine of theta equal 1? Right? Well, this would be at 7 pi 6 and 11 pi 6. And then where does the sine of theta equal 1? That'd be at theta being pi halves. And so I know I have a vertical tangent at pi halves. That's why I threw it out up here. So maybe I should have done it in that order, because I know I can't have a horizontal tangent if I actually have if it's actually undefined there, the derivative there. So, okay. And now we go ahead and say, well, our vertical tangents if theta is pi halves, find your r. And then for 7 pi 6, throw it in, you get 3 halves. And then for 11 pi 6, throw in theta, and you get 3 halves on that as well. Okay. Now, since I restricted, so make a note. Since this was restricted, theta between, I just said negative pi fourths and pi fourths, all right? So the horizontal tangent let's go back up here. The only one that'll work is that right here. The pi 6 is the only angle there between negative pi fourths and pi fourths, all right? So the horizontal tangent is 1/2 pi 6 for my r and my theta. Okay. Now using x equal r cosine theta and y equals r sine theta, you could get that as the xy value. That would be this x and that y. That x and that y. And then the vertical tangent would be that, well, if I'm looking at this, none of these are, and so I'm gonna state it with negative pi 6. So I'm going to use that 3 halves. Instead of 11 pi 6, I'll use negative pi 6. So have one in between negative pi fourths and pi fourths, right? And that, using the x equals r cosine, y equals r sine, that would end up being 3 root 3 over 4 and negative 3 fourths. Again, using those. Well, thanks so much for taking notes. We'll see you guys next time.